right. Do you have any question regarding the Hall probe on the Volta parallel? Do you have capacitance in the test? Yeah, we have capacitors. We just don't have magnetism. The two capacitors. So yeah, Hall probe. Any question regarding Hall probe? You can let me know. The thing is that you need to know the derivation for this equation. The Hall probe equation is Bi divided by NGQ, and just like the notes. I've uploaded them in the classroom. You can just go through it. So we will be wrapping up this topic. Just before I get to the last part, let's just confirm if we have covered everything. Right. So we just have one small part of magnetism left. Discharging capacitor circuits, as in discharging graphs. Drawing the whole circuit. Yeah, so it's this thing that I showed. Remember, if you have like oh, sorry. Yeah. It's basically a two-way switch system. Are you talking about one? Like there's a two-way switch and it goes from one side to the other. Let me just show you this. And, you have a battery here. You're connected to a capacitor. There is like a switch here, and the switch goes this way, and on the other side you have a discharging circuit, so you can move it from this side to that side. Is this the one you're talking about? Oh, what's unique about that circuit? Like, why do we use it? Oh, this is the one, right? So it's either you can draw it. Let me show you. Either you can draw it together, or you can draw it separately. So charging and discharging, right? There was this, yeah, this one. So what you do is you connect it this way, it gets charged. You connect it that way, it gets discharged. Yes. Do you know why? Because if you don't have a resistor, the resistance is going to be zero, right? And the time constant would then be zero, which means that the current that will be passing through would be too high, and it can cause overheating and it can ruin your circuit. So as a safety measure, you put a resistor there to restrict the amount of current passing through. Right, so just a quick check on things that we have done. So আমাদের হচ্ছে ম্যাগনেটিজম একটা টপিক বাকি আছে, it's called electromagnetic induction. Okay, maybe I won't start that today. আজকে I'll wrap up this part, this whole thing here. Okay, so understand magnetic field is an example of a field that provides a force on a moving charge or permanent magnets. We discussed that. Represent magnetic field by field lines. Drawn some of them for you, and then we went to the last part here. Sketch the magnetic field pattern due to a long wire, flat coil, and a solenoid. So remember the class we had where we saw how the coil produces a field, like a doorway I showed you, right? So that one. Understand that magnetic field due to current in a solenoid is increased by a ferrous core. By ferrous core, if you place like an iron core, the strength increases, right? Why does it increase? Because the dipoles in the iron become aligned as well, and it adds to the magnetic field because they're aligned, right? They're also producing their magnetic field. Explain the origin of force between current carrying conductors and determine the direction of the force. This was that diagram I showed you where you place a conductor between the magnet, and the magnetic field of the conductor interacts with the magnetic field of what? The magnet, and the force is generated. The origin of what effect? Motor effect. Motor effect. And then we go to the motor effect. So understand the force might be acting on the conductor placed in the magnetic field. We saw that. But the catch is the force will only act if your current, your flux are what to each other? Perpendicular. Okay. Yes, if it's not perpendicular, you will still have a force. It'll be a lower force. And when it's parallel, there's nothing going on. Recall the equation F equals to BIL sine theta. We have done that. Determine the magnetic flux density as a force per unit. So define. So if they ask you magnetic flux density in your exam, this is the definition. Okay, not the one that makes more sense, which is it's the amount of magnetic flux per unit area, right? They want this one, so you have to go for this one. Okay, this is more based on the equation. So it's a very too easy. You make this a subject. So what should F be? It's the amount of force exerted per unit length of wire carrying per unit amount of current. Okay, where it's perpendicular. So yeah, we have done that. flux is a blue Rutherford field, like a single field, and flux is like a combination of it. So remember, we did something called the flux linkage multiplied by the n. That's actually a flux. How do you find out flux? You find the B and then multiply with the area in which you found the B. So there's a topic I think you have in your exam, electromagnetic induction, and the formula is EMF equals to minus n d phi by dt. The phi there is flux. So in the exam, they never give you phi, they give you B. So you have to multiply the B with the area, and that area is perpendicular to the B. Then you can get the phi. We will do that later on, but just letting you know for your exam. Okay, determine the direction of force on a moving charge. We did this last class. Recall that F equals to BQV sine theta. We did that. Understand the origin of Hall voltage and derive the equation BH equals to BI divided by NTQ. We did that. Understand the use of Hall probe to measure magnetic flux density. Done. Describe the motion of charged particle moving in uniform electric field perpendicular to the direction of motion. What does it do? When a charged particle moves it spirals and goes in a circle. Explain how electric field and magnetic field can be used in velocity selection. That's what we're going to do today. Okay. And then eta hoigale, I will start paper 5. Okay. This is very small. Eta beshi time lagbe na. So eta hoigale, after we are done with this, there's another mechanism chapter out there. It's called electromagnetic induction. It's very important. So eta tomader hocche next week I'll start. Okay. This is like Lenz's law, EMF induction and everything. I understand you have your school exams coming up. So if your school exam syllabus is still magnetism, a part to just baki thakbe. So I'll add like a note on this for you guys. Okay, so we'll just do the school exam also next week. Okay, so velocity selector. Bolo, question? Any question? Our quantum physics asset school exam, right? Quantum, right? What about you guys? Do you have quantum? No, so it's still AC current. Okay, let's look at this device. It's called a velocity selector. What does it do? So velocity selector, the name kind of gives it away, is a device that allows you to select the velocity of particles that are coming out from a source. Very handy. I'll tell you why. So when you have therm ionic emission, do you remember what that is? Therm ionic emission. Have you heard of it? What is it? Therm ionic emission, photoelectric emission. Yeah, the emission part is right. But therm ionic emission, you take a metal coil. Don't worry, we have this later on. We have a chapter called medical physics. In there, we learn about the X-ray machine. And in the X-ray machine, to produce high-speed electrons, we use this filament. And it does something called a therm ionic emission. So what happens is, you take this coil and you connect it to a very high voltage. And as you connect it to a very high voltage, what happens is the coil starts to heat up this filament. It's like a filament lamp, or the filament starts to heat up. As it starts to heat up, at one point, it can't keep the heat in anymore. There's too much energy out there. So what happens? The electrons start to escape from this container or this filament. So what will happen is electrons will move out, and you'll see electrons flying out like that. And the electrons will move out with speeds. Now, the speeds of the electron can vary and will vary because they don't take the same amount of energy to move out. So আমাদের হচ্ছে requirement is that whenever you want to do some experiment, you want your particles to have what speed? Same speed. How do you do this? Like, we just casually throw around that all the electrons are in the same speed. How do you literally manually, right, limit the speed of electrons out there? First of all, we don't see them, right? I mean, even if electrons are emitted, it's not like they show themselves, right? So how do we control their speed? So ওইটার জন্য there's a device here called the velocity selector. And this velocity selector will allow you to select the velocity of your particles. I mean, literally, what velocity you want. Let's say 4,000 meters per second. You can actually set that. How do you set it? We're going to see right now. So to make this thing work, we need 2 plates here, first of all. So you have an electric field to be generated. So you place 2 plates like that, parallel plates next to each other. And you connect one of them to a positive terminal, and you connect the other to the ground or a negative terminal. I mean, ground I connect করতেছি because I want my potential difference to be just the value of V there. Do you understand what I mean? Because if the ground is 0, what is the potential difference? V, right? Our G ground negative to the minus kore bear korte hoto. I think this is easier, okay? And then what I do is I take an electron and I fire the electron into the field like that. And as I fired the electron into the field, the electron will actually experience force due to the field. And we have done this before. Can you tell me an electron negatively charged, right? Etar charge হচ্ছে Q, etar mass হচ্ছে M, etar V হচ্ছে V. This particle enters the field. Which way will it deflect? Upwards, right? And then this is an electric field deflection. And the path it takes is the path of a what? Projectile motion. Very good. So what will happen is you'll see that it does like a projectile motion here. And it'll go and hit the plate at the top like that. This is, or it can go outside as well, doesn't matter, but it goes up. That's the main thing. So this, I'll use a color here for going up here. So the color is blue. Blue means whatever force you're seeing here right now is due to which field? Electric field, right? And do you remember there was a formula for the force in a uniform field due to electric field, right? Let's see if you can retain information from a day before. What was it? VQ by D. Yes, very good. Okay, so yeah, you have a force here, which is the electric force acting upwards. That is Fe, and that is VQ divided by D. And D here is the separation of the plates as we have seen before. Okay, so that is D. Clear about that? So now we'll try to do something. We will counter this movement by placing a magnetic field here. So I want to place a magnetic field in this region so that the electron bends downwards to oppose that. So je uporta chole jacche na oটাকে oppose করে আমি নিচের দিকে electron কে নিতে চাচ্ছি. Can you tell me what magnetic field should I produce between these two plates so that my electron moves downwards? Should it be into the page or should it be out of the page? Question হচ্ছে এই ইলেকট্রনটাকে নিচে নিয়ে যাও। এটা নেওয়ার জন্য একটা ম্যাগনেটিক ফিল্ড লাগবে। কোন দিকে ম্যাগনেটিক ফিল্ড? Magnetic field কি into the page or out of the page? Into. Try করে দেখো। Okay, how many of you think it's into the page? That the electron, so the magnetic field must be into the page. Into, okay, and out of the page, rest of you. Acha, okay, so what are we supposed to do here? We are supposed to first assume that the electron has what charge? Positive charge. So FBI, it's going that way. And if my magnetic field is into the page, which way does the force act? Upwards. So this is an electron, right? So it means that which way is the electron going to go here? Downwards, and that matches what we wanted, right? So yes, very good. It's into the page. So your magnetic field here is going to be into the page. যারা বুঝুনে আবার বলতেছি আমাদের এখানে হচ্ছে I want my electron to deflect downwards, and to make it deflect downwards I need to provide a magnetic field here so that the force is downwards. And turns out that it's possible if you provide a magnetic field that is into the page. So তোমরা কেমনে বের করবে কোন দিকে deflect করবে? You're supposed to use your Fleming's left hand rule. You're going to assume the electron has what charge? Positive charge, and see which way it deflects. And whatever the deflection is, the answer would be the opposite, right? So I'm making an assume that my electron is going FBI that way, right, to the right, and the magnetic flux is into the page. So if that's the criteria, my electron should have bent which way? Upwards here, but actually which way? Downwards, and that's what we want, right? So এখানে যেটা হবে that the electron is supposed to deflect downwards. Now look at this. এটা নিচের দিকে চলে যাচ্ছে. Now, can you tell me what is the formula for the force that the electron experiences downwards? The magnetic force. কি হবে formula? BIL. BQV, right? BQV sine theta. It's perpendicular here, so I'm ignoring the sine theta there. Okay. Now, if these two forces are equal, can you tell me which way would the electron go? Straight. We are going to find out what is it, what's needed to make sure that they're equal and they go straight. So we'll do a bit of math here, okay? So equation I could derive, and the equation will reveal to us what we need to do to make it go straight, right? So to ensure that particle, now it doesn't need to be an electron, any particle moves straight, undeflected, the force of electric field must be equal to the force of the magnetic field, which is VQ by D must be equal to BQV. And you'll find something cancels out. What is it? Q. So velocity selector is very useful because it doesn't rely on the charge of your particle, the magnitude of your particle, right? Also, you'll notice something interesting here. One very important quantity of your particle is not in the equation. What is it? Like a very fundamental mass. It's just the mass also doesn't matter. It's just the charge has to be there, and then you can control velocity. I'll show you how you control velocity. So velocity is going to be what? Any blank page in the topic. This is a standalone topic. It's just like a small paragraph that I'll give you. So V equals to ki ashe ekhane. What is it going to be? V divided by BD. Why is this? By the way, this V is potential difference. So why is this very useful for physicists? So if I want a particle to move through in a particular velocity, this is the potential difference I provide. So potential difference. B is the what here? Magnetic flux density or magnetic field strength. And what is D? Separation of the plates, right? So separation of plates. Once you put these very random physical quantities into the equation, right? What do you get out of it? A velocity. And that is the velocity at which the particle has to move if it has to go straight through. Now let me clarify what it means. It means that আমার যদি হচ্ছে আমাকে একটু help করে, okay? Number তাহলে বুঝতে easier হবে. Let's say my voltage here is 5000. V is 5000 volts. Let me show you কি হয় এখানে. V is 5000 volts. The separation of the plates is 10 centimeters, and magnetic flux density is 0.5 millitesla. Can you find for me what is the velocity? Just say formula mode boshay. Velocity equals to 5000 divided by 0.5 into 10 to the power minus 3 into 10 centimeter and 10 divided by 100. How much is the velocity? 1 into 10 to the power 8. That's right. Very close. 1 into 10 to the power 8 meter per second. You can go faster than speed of light, obviously, right? Anyways, this is the speed. What does it mean? It means that, listen carefully, the consequence of this device, it means that if your particle has this velocity, 1 into 10 to the power 8 meter per second, right? Where will it go? Straight. Okay. If there's a particle that's less than this velocity, it'll get trapped inside. If there's a particle more than this velocity, it'll also get trapped inside. If this particle there's a particle here whose velocity is more than this, then the velocity jodi bere jay, then a force ta beshi hoye jabe. So the particle will start to go which way? Rather down. And if the velocity is less than this value, then that becomes more. And which way does the particle end up? Up. Only at this velocity, where will your particle go? Straight through. So you can send as many particles you want here at any speed you want, but only the particle that comes out will have this speed out there. It's basically like a filter. It filters out all the other velocities and only lets this velocity in. Now let's say I want to lower the velocity I want to send through. Yep, lower your potential difference because that's under your control, or increase your magnetic flux density if that's under your control, right? And by manipulating these values here, you can control what's the speed at which the electrons are coming out from that thing. And eventually we make this thing into this a device that looks like this, right? Press korle tomar hocche electrons ber hobe, and you can have a knob here. You can control the speed at which the electrons are coming out, and there's a name for that device. It's called the electron gun. So basically, physicists they use it to fire electrons, and you can control the speed of the electrons. It basically does that. Okay, so it's this is called velocity selector. So anytime in future, if there's a requirement that you want to set your particle at a certain velocity, use this. And then, by the way, will it work for a positive and negative charge equally, or do I need to make changes for a positive charge? No, because দেখো এখানে যদি এটা positive charge হতো, let's try to think about it. If this is a positive charge, which way will it deflect due to the electric field? Downwards. But then which way will it deflect due to the magnetic field? Upwards. And eventually, because the magnitude of the charge has no role to play here, it just goes straight through. No problem, right? Okay. So it literally does one thing and it does it very well. What is it? Selects the velocity for you. Okay. Yeah. So right now, for this to function, this should be equal to that, right? And if the velocity is this value here, then the particle will go straight through. Now, what if the velocity is a little lower than this? That means this is lower, which means this will become less. And if this becomes less, previously they were equal, by the way. Now this one becomes less, right? So if this one becomes less, which way the particle deflect? Yeah. And what if the velocity is higher than this? Then this increases, and which way does it deflect now? Downward. So the only time the particle can go straight through if the velocity is exactly that value. So it's like a filter for that value. Right, so this is your velocity selector, and yeah, so copy করতে চলে করে নাও. Yeah, it does actually. So if the length of the plates are too long, then there's a possibility that the particles may stay inside. However, for a velocity selector, you're balancing it out, right? So even if it's a very long plate, it's going to be the same equal and opposite in each place, right? So what will the particle continuously do? Go straight. So in this particular setup, it doesn't matter. But if you're having an electric field or just a magnetic field, the length does matter. We did some math, if you remember, the projectile does stay inside or go outside. In this particular scenario, it doesn't matter because you're balancing them out, right? So they'll continue to stay stable and continue to go forwards. Too small? Not a problem, because the moment they enter, they are equal and opposite, right? So your particle will be stuck in the center. So continue to go straight forward. It's not like it goes this way and then goes that way and then figures its path. It's right away going straight. There is one issue though, they usually try to make it a little longer. Let's say some particles are too fast. What they'll do is they'll not go straight, obviously. They'll deflect one way or the other. Sometimes they'll deflect like that. So they might come out of the system. So to make sure they don't come out of the system, we make them long enough so they get trapped inside. Okay, these are not the particles you want. These are the ones to be filtered out. Right, so questions? That's velocity selector, okay? What question can you get from this in the exam? So there's an unfortunate nature of the question they ask you. They'll ask you to do the whole thing. They'll ask you to draw the diagram of a velocity selector and explain the working for 5 marks or 6 marks. And they'll give you like a space to draw the diagram, and niche they'll give you lines to write the answer. So they won't give you like a math from here. They'll ask you to design this and describe the whole thing, okay? Which is good, I think. And it's not that difficult. It's very easy, 6 marks. Clear? Okay, so with that we are done with charges in magnetic field. Our obviously question paper korte giye we will find interesting questions out there, but this is the core requirement of your syllabus. So I'm going to solve a paper 5 today, okay? Like the whole thing. It is possible. Your class is till 5:30 also, right? So, yeah, I mean, every Wednesday till 5:30. Right, so I'll solve the paper in a minute. Like if you have any other questions. Last Wednesday ছিল তো 10 minutes থাকতে পারলে আরো 10 minutes কেন থাকতে পারবে না? The class is from 5 to 6. mean, it's very normal to miss a class. No. I mean, it depends on you. তোমাদের যদি হচ্ছে স্কুলের এক্সামে paper 5 is something that you're struggling with, তাহলে it's up to you to, prioritize what you want. Or you think paper 5 is easy, তাহলে it's up to you. Okay, so paper 5, I will solve a recent paper, March 2024. May June 24 the পাইনি, but দিতে পারি exam এ. Okay. No. Today is the last one before your exam. Velocity selector. It's in the Google Classroom, but it's just. Okay, I'll give you 5 minutes, then we're gonna start this paper. Okay. তোমাদের হচ্ছে you have a test coming up on Sunday or Saturday. Okay, it's everything till capacitors. We solved the paper yesterday morning. If you did the classes in Google Classroom, basically something like that. Okay, one question from every topic we have done. So, well, right. So I'll start in a few minutes, but I finished only bullet key. So what's your paper 5 about? So your paper 5 is a 1 hour 15-minute exam. It used to be 1 hour, so they increased some time. And it's planning, analysis, evaluation. There are 2 questions out there, okay? And the total paper is 30 marks. 1 planning of 15 marks and 1 graph question for 15 marks. Typically, a paper গুলো হচ্ছে খুবই well answered, okay? Because there are some hacks out there that there's no way that you can go wrong. Like now you can get at least 10 marks, okay? Because there's some basic things you talk about, right? So generally speaking, it's pretty well answered. The only problem in this paper is that there's a graph out there, and the graph is either you get full marks or you don't get any marks. There's nothing in between. And the reason behind that is গ্রাফটা করার সময় আমি আজকে গ্রাফটা দেখাবো তোমাদেরকে একটা টেবিল ফিল আপ করতে হয়, and you use the data in the table to do everything else, like find the gradient, find the y-intercept, find this, find that, and everything, right? So if you get the table wrong, it's just natural that everything else will be wrong. So that's the reason why it's and if you get it right, there's no reason you should not find the gradient. I mean, gradient though obviously very straightforward, right? So yeah, that's the reason why sometimes students have a bad exam. It's because it's just gone. There's no partial marks here or then, okay? And a planning journal, if you follow the checklist I'll provide, you should get at least 10. Okay, at least 15 is the mark, but 10 pals, because there are some things that are just very straightforward here or below this. So yeah, that is these are the 2 questions out there. So yeah, before I explain planning and what are the things you need to know. So first, let me tell you something. You can't study for this. Okay, so a lot of students will try to study for this. I'm gonna study for my planning exam, right? It's not possible, because every single question so far, it's like since 1987, that's almost 40 years, right? Every question is unique. They will give you, and they will never run out of questions, because they're not bound by your syllabus. They can ask you anything. They have asked the most random things out there. They try to keep it syllabus mode, but they will ask you things like, if the fan is spinning and there's a balloon flying this way, how does the angle of the balloon change with the fan speed? Came in an exam. There was a thing like a person wants to model the size of a firework. How do you do that, right? So it's an open-ended question. Now, if you try to study for this, there's nothing to study actually. So what can you remember that can make your answer better is a checklist I'm going to give you. And a checklist normally, if you did IGCSE in your O levels, paper 6 planning select, we take. See, it's the same thing. It's just this is like a A-level version of it. So what's going to be complicated here? I mean, that's 7 marks. Why is this 15 marks? You can see they try to do this. So they'll come up with the most absurd equations out there, like roots and powers and squares and cubes and exponents. And ওটা analysis part একটা problem. And it's a math problem. Okay, not a physics problem. So তোমাদেরকে বলবে যে এটার গ্রাফ কিরকম? What graph do you expect here? T versus F versus L. What's the shape of the graph? Right? So that's the problem. So এটা যদি বের করতে পারো, rest of them are fine. এটা যদি বের না করতে পারো, ওই 10 marks পাবা কিন্তু। The 5 marks পাচ্ছ না, যেটা হচ্ছে the analytical part. Okay? So how do we come to that? I'll teach you. There's a way out there. But let's start. So how do you do these questions? So এই question গুলোর জন্য there is a checklist. That's it. All right, so let me start the planning
Recording
part.
in progress.
There's like a checklist that you need to look into. Checklist of theta. It's the same as your O level. So I'll just quickly go through the checklist to see if you remember what these are, okay? So there's independent variable, dependent variable, control variable. Before you start the experiment, right? This is brainstorming. You don't even start writing. Have you recognized these or not? Because let's say you mix up the independent and dependent, right? It's a chain reaction. The whole thing will be wrong. You're doing the wrong experiment, right? So what is an independent variable? What is a dependent variable? What's a control variable? So I think by now you should know. What is an independent variable? Yeah, so it's a variable in the experiment that is under your control, the one that you change. Okay, so this is usually going to be the y-axis of your graph, x-axis of your graph. Because you make a change to this variable, something else must be changing. That is going to be your what variable? Dependent variable. So that goes to the y-axis. But sometimes things can happen that this dependent variable can also vary for other factors other than the one you are doing. So example, the temperature of this table. I have an experiment. Temperature of the table with fan speed. If fan speed change, and I'll see how the temperature of the table changes. Can you tell me in this experiment which is independent variable? Fan speed, right? Because fan speed change, temperature of the table will change. Is it possible that I heat the table up and the fan starts to spin faster? No, right? So that link doesn't work. So it has to be that fan speed is independent, this is dependent. But then I'm doing the experiment, I see the values are all over the place. When there's no link out there. That's because there are other factors out there. For example, a room experiment put together, what's the other factor? AC, right? It's the time of the day. Let's say I did the experiment half in the morning, half in the night. Wouldn't that impact my temperature? So these are external variables that can also cause a change. We need to do what to them? Keep them constant. That's what they're called control variable or constant variable. The word is little, paradoxical because this is constant variable. Constant or variable to opposites, right? Basically, they're trying to say that keep the variable constant. Okay, so yeah, that's the control variable that you have here. And once you have established these, right, you get 3 marks right away. Okay, sometimes even 4 or 5 depending on how many controls are there. So first data established always, otherwise you will have a problem in the experiment. Next, and this is what sometimes students don't like. They want a diagram, and they sometimes make it mandatory. And I would recommend to draw a diagram. And the reason behind that is if you don't draw the diagram, will you not get your marks? No, you will. Your diagram has to be in the description, like what the setup looks like, which is not very easy. That you're going to describe that whole setup in words. Jotei cheshta koro, a diagram does it better. Okay, because you can't fully put it in words. There are a lot of small things that I can diagram and draw kore fella, but you have to write a lot about it, right? So I think the best way is to have a diagram and complement your diagram with some description. Both mile, you will have like a proper answer. Okay, just a description is sometimes very risky. Just a diagram also is very risky. What if you draw something that no one understands, right? Most likely. So you wouldn't really know. The examiner won't be having a scope to give you marks, right? So try to help the examiner. That's the thing, right? So diagram apparatus, you can list out what you need, and you can show how it is. But with the diagram comes a catch, though. Your diagram has to be a realistic version. What I mean by that is not 3D, actual setup, but if you have, let's say, oscillator or a CRO, they want you to show that the CRO is connected to what? Power supply. That's because otherwise, I have no clue about how things work. I take a CRO and I just keep it on the table, right? No wires, nothing, and I'm wondering it's not working. No, because it's not connected to the power supply. I know it's very obvious, but they want you to show those. Okay, for example, you have like a spring hanging in the air. No, okay, you need to have a watch here, like a clamp stand. Okay, a thermometer just hanging in your beaker. No, you need to have like a clamp and a thread or something holding it. Okay, so you have to show that. So they used to say this before economic marks came in, but they said no floating apparatus. Okay, that's what it means. Okay, no floating apparatus. If you understand that, then I think your diagram would be pretty okay, right? So that is your apparatus and diagram. Next, hoche a part. It hoche apparatus are related. It's what we typically call the procedure. It's like how you take your measurements. Okay, so this has some precautions involved in it. Like, for example, you are taking along the length from different orientation, finding an average and those things. That's part. And then with the measurements and everything, what do? You capture the data and you do something with the data. And almost always, I have never seen an exception. Almost always, what do you end up with? A graph, a graph like this. Okay, so you always have to think in the back of your mind, how can I get a graph out of this? Because graphs only get advantages. You can plot the graph, see if there's a trend, find anomalies, find gradient, find intercept, find area, right? It's a very handy tool to have. So always try to go for a graph. Are you supposed to sketch the graph on your script? No, actually you don't need to. If you do, it's fine, but you don't need to draw like a graph and show it to them. Okay, you can just say that the graph would be this versus this, and the gradient will give us that. Okay, you don't need to actually draw the graph. And that is the main chunk here. Around 8-9 marks with the paro. Then comes safety precaution. So just experimental precautions and safety precaution. What's precaution? Experimental, like, reducing parallax error, trying to figure out ways to eliminate some external factor, repeating, find an average, those things, right? Safety is always recommended, just one safety. So if there's a safety issue, acknowledge it and then say how to fix it. Okay, just don't go and say that the experiment is unsafe, right? You have to say what's unsafe there and what to solve, like how to solve it. Also, just don't say wear gloves and goggles, right? Why? So they have to be backed with the reason. Okay, because gloves and goggles such a rod to me vernier caliper to measure, right? Why you need your gloves and goggles? So yeah, it doesn't work all the time. So you have to be aware, where is it appropriate? It used to once upon a time, like, you could just say, put on the full apparatus, like the full set, lab coats and everything, right? They'll be okay with it. But now they want to see, do you understand why are we wearing gloves and goggles and like other safety features? Okay, so safety is a thing. And then comes this bonus point. Let's say you wrote your answer, you think that you get like 14 points, 15 points, you can add an improvement here. So when it comes to improvements, right, it's your imagination. Like, you just use whatever you can imagine to improve your outcome. So let's say you're using like a camera to see a ball bounce, right? Replace that with what? Like a motion sensor, so it precisely does it. Or let's say you're using an ammeter, forget the ammeter, connect the ammeter to a computer so it plots the graph for you. It's better than a person doing it. So those improvements you can add always. There are always improvements in most experiments out there. So yeah, this is the checklist. It does work for almost every experiment we have. Also keep in mind your answer is checked in a holistic manner. মানে হচ্ছে এই pattern or a sequence ওরা care করে না. They want to see, are these points there in your answer anywhere or not? Okay, so what if you start with the precaution? It's fine, and they'll somehow, if you can convince them that the precaution is the first thing to do, they will give you marks. Okay, so অনেকে ভাবে যে I have to follow this pattern and write my answer. No, not needed necessarily. Okay, আর একটা জিনিস আমি recommend করবো, when you write your answer, right, try to at least like write in paragraphs. Okay, because I see students do like a wall of text, right? It's like so tiring to see. I don't think examiners will want to read it. Okay, so paragraphing for advantage, at least you have an idea, have you written the points down in the proper way? How to paragraph? I recommend to use this. Okay, like use those as paragraphs. Each of these are what? One paragraph out there. Okay, so this is what they asked you to do. This is what my checklist is. I will tell you that in the exam, it's best to follow this and look in this if you have gone through those. You get my point? Because they will follow this and write the answer. And sometimes school teachers will look into the mark scheme and they will see that eta follow course or mark be the China. So answer this. But while you answer this, see if you're covering all these points or not. Okay. Right. So that's it. How many improvements should we write? One is maximum. I think two maybe. Okay. But you can't compensate for lack of answer by giving like 10 improvements. Okay, I mean, you didn't write the experiment and you just write 10 improvements out there randomly, or a marks given us. So yeah, a couple of marks maximum. Right, so that is it. Ora ki chache ekdike procedure to be followed. Eta konta hobe? It's basically the apparatus, the measurements and everything. Measurements pore diye dise. Control of the variables. So ekhane jeti importance dise, it means that it's something very important in this experiment. Analysis of the data is going to be what? The graph, the table headings, right? You can do that into write the table headings. Do you know what that is? Like, key corba. So that you can do. Any safety precautions to be taken, right? So that's the procedure. You can use it for any experiment and every experiment out there. Okay, right. So let's try this one. Key hoche ekhane dekhi. Random at the paper. On year 2024 February March. Okay. So let's see what's going on here. It says figure 1.1 shows a thin cylindrical metal rod of length L. One end of the rod is hit with a hammer. A stationary sound wave is set up within the rod. So it's a unit 2 question. Unit 2 naman tomader hocche wave 0 question, right? So sound will travel through this and then it'll form a stationary wave here. The rod vibrates as it at its resonant frequency. A2. What's resonant frequency? Yeah, the force frequency and natural frequency are equal. That's resonant frequency. A microphone is placed at one end of the rod, detects the sound waves emitted from the other. The frequency of the detected sound is also F. So yeah, whatever sound you'll generate here, that frequency is what you detect. The number of rods of different length are available. So you have number of rods of different length available here. It is suggested that F is related to L by this relationship. So frequency is related to L by this equation. So finally, now we have meaning to this equation. So frequency and length, where rho is the density, E is and N is a constant. So E and N is a constant. Plan a laboratory experiment to test the relationship between F and L. So sometimes students struggle to figure out what's independent and dependent. So there's a hack here. Hackta hocche, there's one statement they always write in every single paper ever, which is plan an experiment to do this, this, and this. This statement is the experiment, actually. Everything else there is just supporting the experiment. So this is what the experiment is. What is the experiment? To find the relationship between F and L. Do you understand? So tomra ji kono confused ho jao, what are the things we need to change and what not, right? This is the statement. I can go to any random paper out there. I'll show you this phrase is always there. It has on year 2021, right? A design an experiment. You see that? So that's where the main key part is. Our random paper jai ekhane hocche plan an experiment to find V and V. So always, you'll be bombarded with quantities and constants. That's what they try to do. 1, 2, 3, 4, 5, 6, 6 different things out there. Sometimes students lose it, like konta key, konta variable, konta dependent, right? Forget everything. Just look at that. তারপর আমার v কে চেঞ্জ করতে হবে and d কে হচ্ছে দেখতে হবে এখানে এখন ডিসাইড করতে হবে কোনটা ইন্ডিপেন্ডেন্ট ডিপেন্ডেন্ট okay that you have to figure out but these are the two things you have to work with okay so let's get back to the equation here f and l draw a diagram showing the arrangement so ওরা যেটা আলাদা করে বলে ফেলছে you have to draw it it's not like you may sometimes এটা বলে you may draw a diagram এখানে বলছে draw a diagram so you have to explain how this could be used to find the values of e and n so আমাদের eventually বের করতে হবে e and n কি okay all right so can you tell me এই এক্সপেরিমেন্টের মধ্যে কোনটা আমার ইন্ডিপেন্ডেন্ট ভেরিয়েবল এন্ড কোনটা আমার ডিপেন্ডেন্ট ভেরিয়েবল একটু ট্রিকি আছে কোশ্চেনটা অ্যাজ আ স্টার্ট আই নো আর টু ইজি হলে বেটার হতো বাট দেখি পারো নাকি sorry length is independent and dependent is the frequency that it produces do you guys agree or is frequency the independent and the length of the rod dependent that doesn't make sense, right? Is it like that I put the frequency to a different value and the length increases? No, right? So yeah, this is actually the one you said. So the length is independent and the frequency is what? Dependent. So there's a natural frequency to everything, right? I think I showed this before to you guys. These are all what frequencies? Resonant frequencies. Because resonant frequency in kind of naturally oscillate for it, right? That's its natural frequency. And natural frequency is the resonant frequency, right? Yet our different because the length is different, right? Okay, so that is it. Now I will go through the answer, but I'm going to finish before we start writing the answer, which is how can I find E and N? It's a matter part. I want to see tomra kemne eta tackle koro. Because every year the equation is different. Okay, so one thing that they'll try to make sure is that the way the equations are, they're very, very random. If you look at them, you'll realize that they try to be very random here. Sometimes addition, sometimes exponent, sometimes logarithm, sometimes just this, right? So can you tell me if I do an experiment where f is my independent and sorry, L is my independent, f is my dependent, how do I get the values of E and N from there? Both of them are unknown. So কি করতে পারি দেখো determine the value of E and N can we তা তোমার x axis তো হচ্ছে L to the power n হবে আচ্ছা আমাকে একটু এক্সপ্রেশনটা বলবা what is E and what is N হ্যাঁ করো বাকিরা ট্রাই করো tell me an expression for E and N math question বলো করতে পারো আচ্ছা অনলাইনে some of you recommended something আমি বলবো না এটা কি but it's right you can so tell me what is E equal to and tell me what is N equal to from this equation কি হবে বলো log L by 2 আচ্ছা, okay. আর কেউ? Yeah. What's equal to? Yeah, it is possible. So did you do that? So what's the expression that you get? Like 3 plus things. আচ্ছা, okay. Let's try. কি করতে হবে দেখি আমরা। সো এটা বাই দ্য ওয়ে, যে এই জায়গাটা যদি হচ্ছে একটু প্রবলেম হয়, তাহলে ইউ ক্যান আন্ডারস্ট্যান্ড দ্যাট ইটস গোইং টু বি আ প্রবলেম ওভারঅল। অনেক কিছু এক্সপ্লেন করতে পারবে না। সো এই কোয়েশ্চেনটা ব্রেকডাউন করা শিখতে হবে। সো 2f ln equals to root e by rho. First of all, let's try to understand what's a constant here. So এখানে কোনটা constant? 2 is a constant. This whole thing is a constant as well. That's what they said, right? So the only variables that we have here are what? F and L. So I can then form a relationship between F and L. And from that relationship, I need to make it a straight line, by the way. From there, what can I derive from there? Probably E and N, right? So key করতে পারি, you can do F L to the power N equals to root E divided by rho. আমি যদি 4 rho লিখি, does anyone have any problem? Why is that okay? Yes, okay, ঠিক আছে. Times yeah, so that's this right hand side right now. Okay, তারপর হচ্ছে, what we want to do is we want to get rid of the exponent there. So I can do this, which is L to the power N is equal to 1 by F root E divided by 4 rho. Do you agree with that much? Now, how do you get rid of the n here from the power? You can take logarithm, right? So natural logarithm নিতে পারো or base 10 নিতে পারো, like log or ln. আচ্ছা, because এখানে তো e function নাই, so natural টা নেওয়ার কোনো advantage নাই. So I'll go with log, just normal log. So log l এখানে n চলে আসবে equals to এই পুরো জিনিসটার হচ্ছে log নিতে হবে. So that's f to the power minus 1 times root হচ্ছে e by 4 rho, right? So if I take log on this side, do you know what the identity is for a into b of a log? Yeah, a plus b, you add them. Like, when you take the log of a product, it's just addition, right? So in this case, it's going to be n log l is equal to minus log f plus log কি হবে root over e by 4 rho. Is it okay? কোন কনফিউশন থাকলে আমাকে বলতে পারো, বলো। ওই যে log f to the power minus 1. আচ্ছা, so এই যে এখন যেটা করব আমরা, will now try to figure out how to plot a graph here. So if I want to plot a graph here, গ্রাফটা হচ্ছে তোমার এদিকে আসবে হচ্ছে what is my independent variable? L, right? So I'll take log L by n here, and y axis এ কি আসবে minus log f নিতে পারো. So if you do that, this is what y equals to mx mx দ্বারা, হ্যাঁ উল্টা হয়ে গেছে, দ্বারা এটা এদিকে চলে যাবে, এটা এদিকে আসবে। So আমার এখানে হচ্ছে this is y equals to mx plus c. So it's supposed to be a straight line. Well, you can হ্যাঁ সরি, এটা log f হবে, এটা মাইনাস and না wait, আচ্ছা, just go back, আমি ভুলে গেছিলাম কি ছিল এখানে। Yeah, this was the original one, right? হ্যাঁ, so if I take this one to this side and that one to that side, তাই তো হয়ে যায়, right? আচ্ছা, okay, মাইনাসটা চেঞ্জ করতে হবে না, because I'll tell you why. If I write this as y equals mx plus c, this is what? Y axis. This is going to be what? Mx plus what is that going to be? C. Our m এর মধ্যে x টা তো হচ্ছে log L, right? So what is the gradient of this graph going to be? Minus n, right? So once you plot your graph here, a graph এর মধ্যে the gradient of the graph is going to be where I get my n from, so minus n. And it's not supposed to be this way, it's supposed to be which way actually? That way. জানো কেন? Because it's minus gradient, right? So it's supposed to be the other way pointed. So yeah, you have this, and the y-intercept here is going to be that big expression out there, which is log root e by 4 rho. এখন এক্সামে একটু করে কিন্তু কোনো মার্ক দিবেন, because the mark is not for doing this. The mark is for writing down what is e equal to and what is n equal to. দেখো mark scheme এর মধ্যে this thing is not there. That's why some students struggle with these in the exam. This mark scheme, they don't show the working. When you're practicing mark scheme, they'll directly just go to this thing. So can you tell me what is n going to be equal to? Expression minus gradient. Okay, so তোমাদের এক্সামে এভাবে লিখতে হবে that n is going to be the negative gradient of this graph, and e কি হবে? So we know that log root e by 4 rho is equal to what? C, y-intercept, right? Now, if I want to reverse this, what should it be? 10 to the power C is equal to e divided by 4 rho. And I need what here? E, right? So E is supposed to be 4 rho times what? 10 to the power C to our লিখবো আমরা, because C to আমাদের calculation, you know, what will you write? Y-intercept. বুঝছো? Oh, sorry. Oh, root, হ্যাঁ wait, root স্কোয়ার হবে এখানে, এইটা হচ্ছে না স্কোয়ার না, সি স্কোয়ার, রাইট? সি স্কোয়ার 2 times 10c, হ্যাঁ 8 হয়ে যাবে। Am I doing anything illegal? What's excellent, yes বলো না। এই যে এটা যদি করি c square, right? C square, হ্যাঁ, can you tell me what is x equal to? 10 to the power c square. Can I bring the 2 in the front? No, I don't think so. আচ্ছা আচ্ছা, আমি বলি এখানে অত ঝামেলা করার কিছু নাই। আমরা হচ্ছে এটাকে লিখি হচ্ছে হাফ, আর এটাকে লিখি হচ্ছে 2 root rho. Do you agree with that? আচ্ছা, হ্যাঁ, তাহলে তো হয়ে গেল। আমার হচ্ছে e to the power half হচ্ছে this thing here, যেখানে এটা কত আসবে? 2, yeah exactly, so 2 root rho, and then if I want to get e, what will I do? Root the whole thing. Oh, sorry, square, yes, squared the whole thing. Interestingly, squared the whole thing করলে হচ্ছে 4 rho back করবে আবার 2c, right? আচ্ছা, anyways, আমি তো একটু দেখি, I'm curious যে মার্কস এর মধ্যে what did they give the option as, because এটা e to the power 4 rho, আচ্ছা। Oh, you squared them. আচ্ছা, just a second, এখানে ওরা কি বলছে? Oh হ্যাঁ, it is actually what we got. So ওরা হচ্ছে যেটা পরে আমরা ডিসকাস করছি ওটা করছে, ওরা করছে হচ্ছে 4 rho 10 to the power 2 y-intercept, okay? আর gradient n বলছে নেগেটিভ gradient, so আমি তোমাদেরকে একটু জাস্ট দেখা রাখি এক্সামে মার্কস স্কিমে কি দেয়। এই যে this is what they provide in the mark scheme. They don't show you how to get the value, they'll just say that this is it. Okay, do you know how many marks have they given for this? One. It's 1 mark. Okay, so right. Log f আচ্ছা মাইনাস থাকবে না, হ্যাঁ হ্যাঁ রাইট। Okay, so we'll continue here. A planning technique, you have some idea, right? The main thing is in this part. I want to show you the graph as well, some introduction to the graph. Do you guys have paper 5 in your school exam? Have you done the graph? Because the graph is little complex. So I'm wondering, do you have some idea about it or not? No? Have you done error bars and manual uncertainty application from the second question? Okay. Achha, I'll give you like a intro to it. Okay, Judi Ashe. Because I normally after we're done with the syllabus, I just do all paper 5 questions in one go, February, and then I think like 10-15 questions per day, you get an idea. The students get bored because it's the same thing every year. Okay, so but yeah, you are probably curious what's going on here, so I can take the heads up there. Okay, so a student investigates the electrical circuit here, and the power supply, negligible internal resistance and whatnot. So looks like a complex circuit. You shouldn't worry about it. ওরা এটা নিয়ে কিছু জিজ্ঞেস করবে না তোমাদেরকে, ওরা জিজ্ঞেস করছে that the current is measured using an ammeter here. So এখানে একটা ammeter use করা হচ্ছে to measure the current, and experiment is repeated for different values of R. So we're trying like different values of R here. Ammeter এখানে, sorry. It is suggested that I and R are related by this equation. Now, if you're wondering এটা কেমনে বের করছে ওরা, এটা তোমাদেরকে জিজ্ঞেস করবে না কেমনে বের করতে হবে, but if you're wondering, it's something we did in our AS. It's called the Kirchhoff second law, the loop. You take loops like that, and then you find the value, right? So whatever you apply, anyways, not important because already is something. It says that a graph plotted for 1 by I on the y-axis against R on the x-axis. So 1 by I, and the other one is what? R. So that's the graph. Determine the expressions for gradient and y-intercept. 1 mark again. Okay, so can you try this? This is an easy one. If I plot a graph for 1 by I versus R, what is going to be my gradient and what is going to be my y-intercept? This one is typically very easy. Okay, so E equals to 3IR plus 4IZ, where Z is a constant, I think. Yeah, and RE is a constant. So তোমাদেরকে হচ্ছে basically I versus R গ্রাফটা প্লট করতে হবে। Again, if you have weakness in plotting graphs or deriving equations for graph, it to practice করতে হবে এই টপিকটা। Maybe O levels there's a book called D Rayner. With D Rayner কিছু practice stuff পাবা। R. So the gradient is 3 by E. 4 E. Achha, okay. Right. So what we do here is we take E equals to I common, which is 3R plus 4Z. তারপর হচ্ছে আমাদের হচ্ছে I যদি এখানে E by I is equal to 3R plus 4Z, and then I take 1 by I should be equal to what? 3R by E plus 4Z by E, and that's my Y. That's the Y. That is the R, that's the X, and that's the C, right? So tomorrow exam you have to do this separately. Y equals to mx plus C, and say individually what is what. So Y equals to 1 by I. M, the gradient is going to be what? 3 by E. X-axis is obviously R, and C is equal to 4Z by E. Clear? So that is it. So 1 mark for that. Now, what's next? So next, what's a table data? And if you look at the table and the work I'm going to do with the table, you find that 2 marks is not actually worth it. It's supposed to be like 8 marks. But if you get this right, that mark will come back everywhere here. There's 1 mark of that everywhere here. So if you look at the bigger picture, that table itself is actually 8 marks. Okay, because if you don't get the table, the rest of them will be wrong. So how do we fill the table? Looks pretty straightforward. কি বলছে এখানে? That resistance is provided, current is provided. You want to write 1 by current. That's it. 1 by current. So current কি এখানে? You have 225, right? So how would I find this? So can you tell me what should the value here be? 1 divided by 225. That should be it. But it says something else though. Exactly. Include the uncertainties of 1 by I as well. So you're supposed to find the value of 1 by I and what its uncertainties are. And this is not straightforward. Okay. It is not difficult, but it is not straightforward. So I'll tell you key করব এখানে. First, can you tell me what is 1 by I going to be? Yep. So 1 divided by 225 into 10 to the power minus the value. Oh, how much is it? 4.4. 4 into 10 to the power minus 3. I don't think so. Oh, you didn't take the micro. Yeah. So the micro has to be there. So into 10 to the power minus 6 should be a large value. 4.4 into 10 to the power 3. Right. Now the thing is, do we write 4.4 or do we write 4.44? Or do we write 4? Just 4. So what was the rule? Do you remember this was there in the practicals of your AS, that when you take a data from one part of the table, right, and you take it to the other part of the table and you perform an operation here, operation মানে হচ্ছে minus plus, some kind of mathematical operation. The thing is, what should the value become? Should it maintain the decimal place or should it maintain significant figure? Yes, significant, because always remember down the column, what do you maintain? Decimal place, okay? Because these are the same set of data. And sideways, what do you maintain? Significant figures, okay? So there's going to be 3 significant figures, which is going to be how much? 4.44 into 10 to the power 3. But what about the uncertainty? Is it 1 by 5 into 10 to the power minus 6? How do you find the uncertainty here? দেখো অ্যান্সার করতে পারো নাকি? Average of yes. Percentage uncertainty. You were close. So there's no formula for this. What I'm going to show you, there's only one way of doing it. It's called a manual method. And it says that uncertainty, and you know this, it's not like you haven't heard of this. Uncertainty is always the maximum possible value minus the minimum possible value divided by 2. It's the range here half. Remember the original definition of uncertainty? It's the half of the spread. Now, how do we find the maximum possible value here? So 4.44 is not the maximum possible value. So to get the maximum possible value, what do I use from here? So I know that this number at maximum can be what? 230. At minimum can be what? Yeah, so to get the maximum possible value of 1 by I, what should I use? Minimum value, because it's 1 by I, right? So if you want to get the maximum value of this, shouldn't you take the smallest value of I? Yeah, right? So let's try. Let's use this and find out what's 1 by 220 into 10 to the power minus 6. We'll also find the maximum value, which is our minimum value, 230 into 10 to the power minus 6. Can you tell me these numbers? 4.55 into 10 to the power 3. That's the maximum one, and the minimum one is right, divided by 2. That is the uncertainty. 98.8. Can you divide this by 1000? Because I want to write this in the power of 10 to the power 3. 0.0988 into 10 to the power 3. Do you remember when we write uncertainty, we have to maintain that same power and everything? So what should it be? 0.10 into 10 to the power 3, right? That is the uncertainty for this. And you have to do the same for all of them. And it's only 2 marks. Okay, so what are you going to do for the next one? Let's see. So you're going to first find 1 by this value. And then you're going to find 1 by how much? 190. And you're going to find 1 by 180. Put them here. Find their difference. Divide by 2. Find their uncertainty. And then do that. Okay? And you're supposed to do the same for all of them. Now, the argument from their point of view is that why are they not giving you like 200 marks for this? Well, that's what students want, right? Yeah, you're just doing the same thing. You're just changing calculator values. So the idea that you're using here is just a 1 mark idea, right? So they can't give you more marks here. There's no mark for changing calculator values. Okay. So yeah, anyways, that's what you do here. And you'll have a table. Or exam, unfortunately, marks made answered that, huh? I'll check pretty. Some values. So they didn't give powers. They wrote full values, 4440. Okay, which is fine. Yeah. So all the values go to Boli 5, 4. I want to show you what to do with the graph. 5.41 into 10 to the power 3 plus minus. Baki gulo uncertain or that. They just gave one as an example, and they said 90 থেকে 110 এর মধ্যে থাকলে হবে. Where did they get that idea? I don't know. But anyways, so yeah, you'll have values here. You'll have what here? Uncertainties. And that's where you get your 2 marks for. Then they said, plot a graph here with, what did they add here? Error bars. What are error bars? Error bars are one of the best statistical graph approach out there. Okay, I'll tell you what they are. So what you're going to do is you're going to plot a graph right now. And graph should be the key because they already are giving you a lot of trouble here. They give you access. Don't access a lot. It's all done for you, which is a bad sign. But they are showing you that they can access plot for 9. It's something else that you should be worried about, right? There's O levels to access delay, which you get a couple of marks. So So what's the plot going to be? The first one is 1.25 and 4.44, right? So I'll show you কি করতে হবে. 1.25 is somewhere there and 4.44 is somewhere here. When you plot your plot in the exam, you have to put a dot and you have to draw what around it? Circle. Now remember O-level say students used to put a cross like that, which is fine. But A-level say it doesn't really make sense because that circle that you draw there is basically the range that they mark you for. So the O-level also bolto that the plot should be nearest to the half square out there. Do you know what it means? That your plot can be here, it's fine. Your plot can be there, they'll still give you marks. It can be here, they'll still give you marks. Anywhere in that circle, they'll give you marks. But if you go beyond the half square and come here, you lose marks. Okay, so there's actually an invisible, I'll show you key. There's an invisible circle in which your answer should be. If you go beyond that invisible circle, or a mark given. I'm not really sure, okay, to strictly check kore naki, but the rule is that this is the acceptable range, half the squares. So if you draw it, it's easy for you, okay? So that's first plot. Let's say the second plot is here, which it isn't, but I'll just give you an example. Maybe the third one is there. Fourth one হচ্ছে কোন এক জায়গায় best fit কেমনে draw করতে দেখায়. So yeah, these are our plots out here. Maybe one more out there. So they said to include what here? Error bars. So what are error bars? Error bars হচ্ছে on the graph, you have to show your uncertainty. How is that so? It's actually very easy. Our uncertainty was 98, right? Like 100. What you do is your value here is 44 point, how much was it? 4.44 plus 0.1. That's 4.45. So 4.45 is that number there. And minus যদি করি 4.44 minus 0.1, 4.35, which is down there. This is what you call an error bar. What is the advantage of this? So somebody who's looking at the data can look that the point is here and knows that the point fluctuates by how much. That. So you have now visually represented what on the graph? The uncertainty. Okay. So এরকম করে করে error bars, by the way, vary করে. So let's say এটা error bar বেশি আসছে because uncertainty depend করে. করতে করতে কি করব আমরা error barটা দিয়ে? Let me show you. So let's say the final error bar is like this. Okay. What do we do with this information? Why are we drawing the error bar? So listen carefully. Exam, they'll ask you to draw the best fit line out there. So what's the best fit line? A line that passes through. What's the best fit line? A line that passes through all points. Yes, it's a line that doesn't need to pass through any points. It's a line that passes through such a place that it's closest to all the points. Okay, so it'll be something like this, maybe in this case. Is this fine? Yes, because do you see that they all actually pass through the circle? So that's my best fit line. Then they'll say on the same graph, draw the worst fit line. What's the worst fit line? So worst fit line হচ্ছে taking into account the uncertainties, what's the worst graph that you can get? And there's actually a limit to the worst graph you can have. Beyond that, it's not, it's not acceptable anymore. So what's the worst possible line out there? So what you're going to do is take your plot from the top here. By the way, if my plot was at the top here, am I not still within the range of uncertainty? And if I go to the bottom here, am I not still within the range of uncertainty? So if I draw a line from the top to the bottom there, it's still a correct line, but it's the worst possible line out there, right? The worst extreme out there. There's another worst extreme out there. Right. And I don't know if you have noticed what's happening here. This red line is the plus uncertainty value. The blue line is the minus uncertainty value. And the black line is the actual gradient. So the amount by which this gradient and that gradient fluctuate is the uncertainties of the graph. And that's the next question. Find the gradient and find the uncertainty for your answer. You don't calculate it, you measure it from the graph. Okay. Anyways, this was just a brief discussion of what to expect from this. At a point A, you'll get used to it. Okay.
Recording stopped.